Okay, so we're looking at section 4.4. Asked you to try number 1 on your own. So, Michaela, were you able to find the GCF on number 1? It would be more than just 20. It actually would be what? 20x. Okay? So on number 1, when you were trying this, you should have factored out a 20x. After you divide everything by 20x, you're going to get x squared minus 11x plus 30. Now to figure out whether or not this can be factored more, we look at this part, this trinomial, and we say, are there numbers that will multiply to be 30 and add to be 11? What do you think? Are there? What are they? 6 and 5. So this is now going to factor down to 20x, and then this can be factored down further into x minus 6 and x minus 5. And that would be the complete factorization. So that's what the type of thing that we're going to be trying to do today. So now let's flip over to the front, page 93, factored completely. To have something factored completely, no factor can be factored further. Factor by grouping. This is going to be new for you. This is going to be when we have 4 terms. We're going to look at GCFs for pairs of terms. And that'll make more sense as we try one of those. Quadratic form, all that means is a trinomial or binomial, could be that too. But the trinomial that we usually see quadratic form is ax squared plus bx plus c. That means quadratic form, standard form as well. Okay, down here, this kind of factoring. This is going to be new for you as well. When we have the addition, meaning sum, of 2 cubes, that can factor down into a plus b times a squared minus ab plus b squared. This is a formula that you're going to have to memorize, and the faster you can memorize it, the better. So we have the formula for the sum of 2 cubes as well as the difference of 2 cubes. Remember, difference just means subtraction. And this formula goes down to almost the same thing. Look at how similar these look. This is a plus b, this one's a minus b. This is a squared minus ab plus b squared, and this is a squared plus ab plus b squared. So they're very similar. In fact, I could actually write them both together like this. A to the third plus or minus b to the third is going to be a plus or minus b times a squared minus or plus ab plus b squared. So what this would be saying is, if you have a plus, you're going to go plus minus plus. If you have subtraction, you're going to go minus. If it's subtraction, it's going to go minus plus plus. Okay? So it's a real quick way to just write one of them instead of both of them together. So they showed us an example here. So we would have to know what the cube root of 64 is to be able to do this problem. So you would want to look at your calculator, and your calculator can do cube roots for you. If you just go under math, and you scroll down to number 4, that's where cube root's located. So if you didn't know the cube root of 64, you could have the calculator do it for you. And it tells us that the cube root of 64 is 4. So that's what we would be checking for. Is this a cube right here? Is it a perfect cube? And it is. So in this case, we would say a then is 4x. That's the cube root of 64x to the third. B, we would say, what's the cube root of 1? Everybody should know that. 1. And so now applying our formula, look what they got. A plus B, A squared, they had to square this whole thing, minus A times B plus B squared. Okay, so see how that works? All right, what about the next one? What's the cube root of 27, everybody? So it's going to be 3x, right? That's going to be our A value, because that's our cube root. Charlie Hall, what's the cube root of 8? 2. And so now writing our formula then, it's going to be A minus B, A squared plus AB plus B squared. So see how they got that? All right, so we're going to try one of those right now. I want you to flip over to the other side. And I want you now, without looking back, I'm going to write the formula right here for you. The combined formula is A to the third plus or minus B to the third. The formula was A plus or minus B, A squared minus or plus AB plus B squared. And I want you to try to use that without looking back on number 3. If you get stuck, you can look up here, but I want you to try it on your own. Did most of you get it? Understand the signs? Because it's addition, I had to use the plus minus plus, plus minus plus. A squared, I had to square that whole thing. This right here had to be A times B. In this case, A times B would be that. All right. So now let's look back over here, and I want to discuss some other types of factoring. So the first thing we're going to be looking at is the number of terms we have. If we have 2 terms, we're going to be looking for a couple of different things. First thing we're always going to look for is the greatest common factor. That's number 1. The reason we want to do that is because our numbers will get smaller and easier to work with. Another thing we might have is if we have 2 terms, is we might have the sum or the difference of cubes. So we're going to look for that if we have 2 terms. The third thing we might end up having is the difference of 2 squares. We've done a little bit of the difference of 2 squares, but not a whole lot. So let me just show you an example of the difference of 2 squares. That would be if I had 9x squared minus 16y squared. The reason it's the difference is because it's subtraction. There is a square root of 9, there is a square root of 4. So this is the difference of 2 squares. So if we wanted to factor it, Joey, do you know how we would factor it? (3x) 3x and 3x. See, this always goes down to just a plus b, a minus b, is how it factors. So a, in this case, is the square root, which would be 3x, with the square root of 16y squared. So it's going to be 3x plus 4y and 3x minus 4y. That's how the difference of 2 squares works. Does that seem familiar to everybody? So whenever we have 2 terms, we're going to look for a GCF, sum or difference of cubes, difference of 2 squares. If this had been a plus, it could not be factored. because it would be the sum of two squares. Okay, the next thing, we could have three terms. Again, we always look for a GCS first. Second, if we have three terms, is we want to do a guess and check. That's really all there is to do with three terms. The last thing we can have is four terms. When we have four terms, we still always look for the GCS first, but this is also where we're going to group into two groups of two. Group into two groups of two. Alright, so these are the things we're going to be keeping in mind. In order to have something completely factored, nothing can be factored further. Let's go over to the back now. Let's look at number 2. The first thing we always want to look for is the greatest common factor. So something that these can both be divided by. So I would take out an m, and I would be left with m to the 4th minus 81. I now have two terms. So I want to see, do I have the sum or difference of cubes, or do I have the difference of two squares? Can I take the square root of each of these? Yeah. So this is the difference of two squares. So this can be factored down. Maya, do you know how it would factor down? Good. So that's how it's going to factor down. To have it completely factored, though, I have to make sure all my factors can't be taken down further. So that one I can't do anything more with. This is the sum of two squares. Can't do more with that. But this is the difference of two squares again. So I have to go further. So this is just going to stay as is. This one can't do anything with that. But this one can go down further. And Ty, how does that one go?
M plus 3 and M minus 3.
Good. And now we're finished because nothing can be broken down any further. Got it? All right. What about number 4? The first thing we always look for is a GCF. What can I factor out on number 4? T to the what? Third. So I'm going to take out t to the third. When I do that, I'm left with 5t to the third plus 2t squared minus 5t minus 2. Well, now I have to look at the fact that I have 4 terms. See, look, guys, here's 1, 2, 3, 4 terms. I want to group these into groups of 2 now. Actually, though, before I finish this one, I want to come down and do an easier problem with you. Let's come down here first and do grouping with this one. We'll go back up to that other one. See how here we also have 1, 2, 3, 4 terms? So I'm going to look at these 2 terms and these 2 terms. And I'm just going to take the GCS out of this. So what can I factor out of these 2 terms? A to the what? So I take out a to the third, and when I do a to the 5th divided by a to the third, so here's a to the 5th, divided by a to the third, I took one too many out. It's going to be a squared, isn't it? So a to the 5th divided by a to the third is a squared plus 1. Now, out of these 2, I can't take anything, but I have to take something. So what I'm going to do is I'm going to take out a negative, because of this minus here, a negative 1. So if I do negative a squared divided by negative 1, what's that going to be? A squared. And what's negative 1 divided by negative 1? Plus 1. And so now I'm going to look at this term and this term. And what do those two terms now have in common? A squared plus 1. So I'm going to factor out an a squared plus 1. And then what I'm left with is, if I take an a squared plus 1 out of here, I'm left with an a to the third. If I take an a squared plus 1 out of here, I'm left with just minus 1. But now I have to check. This can't go down any further, but this is two terms. So I have to look. Is it the difference of two squares? The difference of two cubes? What is it? It's the difference of two what? Cubes. So this one's not going to change, but this is going to go down to the cube root of this minus the cube root of that, and then it's a squared minus a times b, plus rather, a times b, which would be a, and then plus 1. And so this is what we're going to end up with right here. Go ahead. For the next one, hi.
Hey, that was your computer.
It's okay. I'm just making a video right now for her lesson, but